Hey everybody, Dr. A here, and in this video, we're going to be providing some background information on matrix inversion, and then we're going to go into a little bit of detail into investigating if two given matrices are inverses of each other. So let's go ahead and get started. First, we want to say that the inverse of a square n by n matrix, let's call it A, its inverse is going to be denoted as A with a superscript -1. And A with a superscript of -1 is another n by n matrix that exists such that A times A superscript -1 is equal to A superscript -1 times A, which equals the identity matrix. Now let's talk about this a little bit before we move on to the next sentence. First of all, you want to remind yourself, what is an inverse? In general, in mathematics, an inverse in math is really any operation or any entity that will undo something else. So we can think of the inverse of addition as subtraction. You could think of the inverse of multiplication is what? Is division. You can think of the inverse of differentiation as what? Integration, okay? And there's a lot of other examples, all right? Now, so similar to other elements or branches of mathematics, your square matrices may have an inverse, all right? Now, not all of them will have an inverse, but some of them will, okay? And again, that inverse is denoted with a superscript of -1. Now, I want to be very clear, this superscript -1 is just a label. It does not mean raise it to the -1 power. So let's discuss this. I'm going to put like a little cloud over here and have a little reminder here. So you want to write this down in your notes. When we're talking about real numbers, if you have the real number 2 raised to the -1 power, what is that going to equal? Well, that's going to equal the number 1/2, okay? So we can say that the number 2 and the number 1/2 are inverses of each other. They're also reciprocals of one another. Now, if you multiply them together, if we say 2 times 1/2, you get the identity real number, which is just the number 1. So for real numbers, when we're dealing with just single real numbers, we can think of this raised to the -1 power as both a reciprocal operation and an inverse operation. So for real numbers, it turns out that their inverse is the same thing as their reciprocal. But in general, a reciprocal and an inverse are not the same thing, okay? For real numbers, they happen to be the same thing. But for many other things in math, you can't say 1 over something is that something's inverse. That's just not going to be true. Okay, it's the reciprocal, but it's not the inverse. All right, so this superscript here is just a label when we're dealing with matrices. So we're just going to call this a superscript to the -1. That is going to be called A inverse, and that's the notation for the inverse of matrix A. Now let's talk about what's happening over here. Okay, if you watch my previous videos on matrix multiplication, we know that in general, matrix multiplication is not what? It's not commutative, which means that in general, if you have two matrices, A and B, for example, and you say A times B, that will not be the same thing as saying B times A. So in general, matrix multiplication is not commutative. But when we're dealing with matrix inversion and we're dealing with two matrices that are inverses of each other, then we're going to have a special case where matrix multiplication is commutative for that specific case. So that brings us to our next sentence here. If we are given two matrices, let's call them A and B, and want to investigate if they are inverses of each other, we must perform both of these following operations. We have to perform A times B, and we have to perform B times A. So what happens is if A times B and B times A both equal the identity matrix, then we're going to say matrix A and matrix B are inverses of each other, okay? So here's the counterpart to that. If AB does not equal BA, then that means at least one of those products will not equal the identity matrix, and then A and B will not be inverses of each other. So again, to investigate if two matrices are inverses of each other, you have to check both of the types of multiplication, A times B and B times A. And if they're equal to one another and equal to the identity matrix, then sure enough, A and B are inverses of each other. So remember, it's not enough just to check one of these products. It's also not enough for AB to equal BA. You got to check both of the products. They have to be equal, and they both better equal the identity matrix, okay? And if that's the case, then A and B will be inverses of each other. So let's do an example. Let's do a quick numerical example. I'm going to scroll down, and I'm going to say example. And I'm going to say given. And I'm going to say, I'm going to ask us to determine if the two matrices are inverses of each other, okay? And so I'm going to give us a matrix B, and we're going to say that matrix B is equal to 1, -2, 1, -1. And I'm going to say we have another matrix C, and that's equal to -1, 2, -1, 1. Okay, now what are the sizes of these matrices? Well, they're both 2 by 2 matrices, so we are going to be able to multiply them together, and we'll see that in just a second. So again, under solution, we need to investigate. We're going to say investigate if BC equals CB, and it equals the 2 by 2 identity matrix, okay? So let's perform this first multiplication operation to get started. We're going to say BC equals, and I'm just going to recopy these, multiply by -1, 2, -1, 1. And I'm going to go ahead and just kind of put the sizes down here. And if you remember, in order to be able to multiply two matrices together, the number of columns in the left matrix has to be equal to what? It's got to be equal to the number of rows in the right matrix, okay? In the right matrix. So we can go ahead and say this equals. Now, what is the size of the product here? Well, the size of the product will also be a 2 by 2. Because why? Well, remember the size of the product here will have the number of rows equal to the number of rows in the left matrix, and it'll have the number of columns equal to the number of columns in the right matrix. If you're a little rusty on matrix multiplication, go back and watch one of my previous videos where we specifically spend time on matrix multiplication. All right, so what we're going to do now is we're going to get this first entry, we're going to say row 1 of matrix B times column 1 of matrix C. So we're going to say 1 times -1 plus -2 times -1. Now I'm going to make this, just expand this out just a little bit so I have more room here so I can show all my work for everybody. Okay. Now, what about this entry in row 2, column 1? Well, we're going to say, I'm sorry, row 1, column 2. I said that backwards. I'm going to say row 1 of B times column 2 of C. So I'm going to say 1 times 2 plus -1 times 1, okay? Oh, I have a typo there. I felt a disturbance there. So we're going to say, well, let's see, 1 times 2 times plus -2 times 1. I'm so sorry. If you caught that mistake there, good for you. -2 times 1. There we go. Okay, what about row 2, column 1? Well, we're going to say row 2 of B times column 1 of A. So we're going to have 1 times -1 plus -1 times -1, okay? And then finally, we're going to say, for the 2, 2 entry, we're going to say row 2 of B times column 2 of C. So we're going to say 1 times 2 plus -1 times 1, okay? And so we're going to end up computing all these values. And again, be very careful when you're collecting all of these values together. When you multiply all these together and add accordingly, you will get 1, 0, 0, 1, which is the 2 by 2 identity matrix. Are we done? No. Remember, we have to check both of these operations. So now what we got to do is compute C times B and make sure we still pop out the 2 by 2 identity matrix, okay? So now we're going to say C times B, and we're going to multiply them in a different order, in the opposite order now. 1, -2, 1, -1. There we go. And we're going to go ahead and open up a big matrix here. And again, that's going to end up being a 2 by 2. So going one at a time, we're going to have row 1 times column 1. So we're going to have -1 times 1 plus 2 times 1. Let me write that a little better for us. 2 times 1. Then we're going to say row 1 times column 2. That's going to be our next entry here. -1 times -2 plus 2 times -1. Okay, then we're going to say row 2 times column 1. It's going to give us -1 times 1 plus 1 times 1. And then finally, row 2 times column 2. So we're going to have -1 times -2 plus 1 times -1. All right, so when we collapse all of this down, we're going to get CB equals, and you can punch this through and check me, but you should end up with 1, 0, 0, 1. And of course, this is still, this is the 2 by 2 identity matrix again. So we're going to finally say that since BC equals CB equals I 2 by 2, matrices B and C are inverses of each other. All right. So that concludes this example, and it also concludes this video. So again, in this video, we really just wanted to show that to check if two matrices are inverses of each other, you gotta multiply them together in both directions, and both of those products should equal the identity matrix. And if that's the case, those two matrices are going to be inverses of each other. If you're a little rusty on your matrix multiplication, check out my other video, and be on the lookout for the next video where we're going to discuss how to determine what an inverse matrix is given a particular matrix to start with. So we'll have that in the next video. Thanks for watching. Please hit like and subscribe.